Hi guys, today I would like to show you how you can interact directly with Ethereum blockchain. So for developers there is a tool called Geth, which is a Go implementation of Ethereum. There are also versions of C on C++ and Python, I believe, but the most used one is Geth. So in order to interact with this, you have to install this. Here you can find how you can install it. It's a standard installation process depending on your operation system. Mine is Ubuntu, so I did the steps to install this through Ubuntu. So if we open the command line interface, we can run Geth to see if it's installed. We'll run help. You can see that I have this command up and running. You can read here options that you can send. There are lots of options, and I don't want to get through all of them now. I will show you just basic usage. So after you install it, I prepared here a list of commands that I used. I tested them before, so I prepared them this time, so we don't spend too much time on investigation. And I will show you. Now, if I would run, let's clear. If I would run Geth this command for the first time, this client will download all the Ethereum blockchain, which is I believe at the moment of this recording is 400 gigabytes, which is a lot. It would take a lot of time. And by the way, I tried before I tried to download this, and it took a lot of time. Now if you can see, my chain data is 59 gigabytes. I will tell you now how I did this, and you will understand. So instead of running a full node, let's say, you can give it an option of how to sync the blockchain. You can choose fast and light. Fast, it will be the same, it will have the same structure, but it will be so-called pruned, meaning that they will cut some headers. Somehow they will archive this database so it's smaller in size. But after you synchronize all the headers, you will still, after this moment, you will still have the full blocks, meaning that your database will grow very hard, very high, because it will grow like 1 gigabyte per day and even more. I will try to run this command now just to show you. I will stop it. Cache, meaning that cache size default is smaller, but we choose 124 for faster development. It will break this in bigger chunks. And console, so we can interact during this process. So let's try to run this command, and we will see that we are getting the Geth version. We set the chain data, which is the blockchain address, where it's a blockchain directory, which this is downloaded cache and so on, chain ID. We can see that the network is 1, meaning that we are on the main net. And also this is telling us Ethereum Geth chain data. We don't run any light version, we don't run any test blockchains, we run the main net. So other information, export port. This is a port where outside machines can connect to our blockchain. So we can see that the block synchronization started, and this will download all the blocks which are on the blockchain. This process is getting a lot of time, and I will stop it because I want, for demonstration purposes, we will use a test network, which is also a public network, but it's a test and it's smaller and it's a little bit faster. So I will stop it now, because as you can see here, this chain data is now 59 gigabytes, and it will, if I will not stop it, it will grow and grow and grow, and it will eat up all my space on the hard drive. Okay, we stopped this. It took some time. Yes, database closed. Now let's clear this. So you can choose to run light mode. I tried it, but it's also taking some time, and I didn't have enough patience to wait what will happen in the light mode. Okay, when you have this Geth installed, you can create new accounts. There is a link here. I will link, by the way, all these links in the description of this video, but after you have this client installed, you can run multiple you can interact with the blockchain. Let's say you can create new accounts, update them, lock, unlock them, a lot of operations which you can do with this, change password. We will review some of them in this video, the most important at least. So let's run account list to see all the accounts that I created. Get account list. This is displaying all my accounts, and it's on real, on the mainnet. Of course, I don't have any money of this. I just played around with this to see how it works, how unlocking, locking works, and so on. But you can see here that I have this account list. Now we will use Rinkeby. We can do the same, but with Rinkeby argument, which will mean that it's exactly the same blockchain structure, and all the commands and interaction is exactly the same. The only difference is that we will use now this minus Rinkeby argument in order to connect to the test network, which is smaller and easier to interact and to test. Because first of all, the reason is not only that it's easier, but it also there is no real ETH, no real money, so you don't have to worry about losing some funds. So it's easier to test and to showcase this. So in this Rinkeby network, I have only one account with some Ether in this. I will show you later how I can check my balance, but as you can see, the only difference is just that I add this additional argument. Now let's start the blockchain synchronization and start this command, which let's start so we don't lose too much time, and I will explain you what we did here. So if we compare this command with the first one, the difference is that we added Rinkeby, which will connect not to the mainnet but to the testnet. RPC, meaning that we will open a remote procedure call, remote procedure call, which will allow outside machines to connect to our blockchain. You can read more information about this. It's a very detailed explanation of how RPC, IPC, inter-process communication works. I will not go too deep into this. You can always check this on the internet. I will link this link in the description as well. So coming back here, this is the difference. We didn't need this here because we just wanted to synchronize the mainnet, but this time, since we want to do remote connection to this blockchain, we need to specify this argument. Also APIs. These are some JavaScript APIs which will help us to interact with this blockchain. This is integrated in Geth, but one thing to keep in mind is that you can import as a node and as an npm package all the Web3 API, and you will have access to this API in your web project. We will discuss about this later when we will show a tutorial about how to interact with a blockchain through a web interface. Console will mean that we can run also different commands during this program execution. So as we can see here, we imported the chain segments. Let's see, we first of all connected to the chain data, which is, by the way, 3 GB full Rinkeby blockchain. I can show you here Rinkeby. If we check the size, it's, come on, I think it's a little bit slow, but with the testnet it's not so slow like with the mainnet. Okay, so as you can see, it's 3.2 GB, so it's not that big. It opened a HTTP endpoint. This is because we specified RPC, and IPC endpoint to which we can connect. I will show you later how we will connect through Mist, which is a Ethereum web-based browser with which we can interact with a blockchain. So all the blocks are mined. Rinkeby is proof of authority, so I cannot mine blocks myself, but I don't also need this. For the purpose of this demonstration, I don't need to mine. But as you can see, the average block time is 15 seconds. So here, every 15 seconds, it will be imported a new block. Blocks 1, 1, 1. As you can see, if you check 49 is 1, 2, 3, 4, 4, which is more or less medium, because if 50 seconds and in 1 minute we can mine 4 blocks, which is okay. The blockchain is running well, it's synchronized, and everything is fine. We can proceed to our testing. Okay, what next we can do? We can attach to this blockchain in order to run some command, because I can run some commands here, like for example personal, let's say, but it's hard to work because all these logs are written, and it's better to attach a new command line to this. I will do this now. Let's run this command. This will attach to my Rinkeby IPC. Here it's an welcome to the JavaScript welcome to the Geth JavaScript console, where I can run different commands. Mist. Let's review what we can do with this JavaScript console. We have access to different APIs, like we discussed here. We have access to these APIs. So for example, if I run here personal, I can see that what functions and variables we have here. All my accounts. This is my accounts on the Rinkeby testnet. It's locked, URL, and all the functions that I can run. I can run Web3, for example. To see, I can run which is a lot. Like you can see, it's a lot of information here, a lot of functions, utility functions, very informative. It's a lot. We need, with these functions we can build our dApps, which stands for decentralized applications. This will help us in future to build web interfaces in order to interact with the blockchain. We can run ETH, which is another API related to account, and so on. So let's try to do some test here. For example, I can check my balance with this function. As you can see, we get the Web3 API, call the function from way, which will transform from way to Ether, get the balance of this address, which if we call it .coinbase, it's this address. We can run the same command, but instead of this we can specify which address exactly do we want to check. Let's do one test, and you can see we have the same result. We can even run functions inside. So if we copy, it's like a JavaScript console. It's not like, but it's a JavaScript console where we can write this function, and after this we can call this function. Check all balances. If I would have more accounts here with different balances, it would show me here. Let's make it bigger. It would show me here what account and the balance of each account and the total balance at the end. But I have only one, and that's why yes, it's only one here. There is a lot of functions here. We will go more in depth when we will have a video of how to create a web interface to interact with the blockchain. But for now, this is it. What else we can do? We can interact with the blockchain from Mist, which is more user-friendly application. Let me start it, and after this I will explain it. I will open a new console, and what here it will do, it will start Mist, and I define to which IPC to connect, because if I would not provide any arguments, it will try to connect to the mainnet. But if I provide a running IPC path, it will connect exactly to this path. It will take some time to do this, but at the end we should see this web browser working. With this we have a more user-friendly way to interact with our account and with the blockchain. Let's see what's going on. Yes, so you can see that I have this amount of Ether in my account. Let's try to send some Ether to this account. I have another account on Rinkebit testnet through MetaMask. We discussed MetaMask in the video before, so check this if you are not familiar with this. I will put my password, and here as you can see I am connected to the Rinkebit testnet, which is the same like we started with Geth. Let's try to send some Ether to this address. Yes, So let's try to send some ether to my address. I don't need this, I need this one. This is my main account in Geth. Okay. I could import it from here, but I don't want it because I want to test. So if I would send from here some ether, let's say 1 ether, next. So I'm sending from account 5 here to 087, 1 ether, and I'm sending. It should take not more than 15 seconds to propagate through the network, and after this we should be able to see this here. If I would call this command here, not yet, but it should be here soon. 139. Okay, now it's 239, so this means that we have this in our new account, and it should disappear from the MetaMask account. Sorry guys, the computer is slow because of all this blockchain. So it's fine, it disappeared. Okay, what else can I show you? I could show you how you can interact more with your account. You can see, you can check this in this link, managing your accounts. We will talk later in a future video how we can migrate with Truffle on public net, because in previous tutorial we saw how we can migrate in the built-in Truffle blockchain, but this time we will see how this process works in real life, in real blockchain. This is for the next tutorials. I made this. I remember I made another list here. One is for Web3, interacting with Web3 API, but here Genesis also for developing your own blockchain. Maybe later I will show a video about this. So that's it. These gifts are private because I don't want to, for now, to put them public, because it's about real money, and I don't want to be in charge if some people will make something wrong with these scripts. But if somebody will require, I can make them public. So that's it for now. This is how Geth and Mist work together, how we can interact with the blockchain, how these APIs are working. Keep in mind that these are useful when you're building web interfaces, which we will review later, but for now you can use them here just to play around.